Hi, everyone. So in this video, we're going to be covering why these three triangles are all similar in this image, right? We've done questions involving this and using that rule, but I didn't really explain the rule enough. So someone asked about it, so I'm just making a quick video just on this one topic. So first of all, what are the three triangles, right? So there's this triangle here, right? ADB. Then there's the big triangle, right? ABC. And then there's this other smaller triangle, right? BDC. Now, why are they all similar? Okay, I'm going to explain that in 1 second. So let's assume we knew the angle of A, right? And let's say that was 57. Okay. In the big triangle, since it has to add up to 180, we would do, and this is a right angle for B, C equals 180 minus parentheses 90 plus 57, right? Which equals 180 minus 147, which tells us C is 43, right? So these two angles, A and C, right, in the right triangle, the two angles that aren't the hypotenuse always add up to 90 together. So we could have just done 90 minus 57 and gotten, you know what, not 43, 33. Okay, so we'll do 33 here. And that is angle C. Okay, so now we have the angles for that triangle. That's ABC. Right. Now let's find the other angles in the smaller triangles and see what happens, right? So let's find DBC. Angle DBC equals 90 minus 33. 90 minus angle C, so 90 minus 33, which gets us 57, right? So this angle here is 57, which if you look, right, we have 57 there. So now we have BDC is the same as ABC, right? And then we have ADB, right? So there's a couple ways we could find this angle, right? We could do 90 minus 57 because it's a right triangle, or we could do 90 minus 57 because of the triangle it's in here in the little one, right? So angle ABD, not all but dissertation, just ABD, right, is 90 minus, I'll do the angle A method, equals 90 minus 57, and that gets us 33, right? So that goes here. And again, it's like angle C. So then in this one, we have A, D, B. So these three triangles are all similar to each other, right? All similar. So that means each individual piece of it is proportional to the other pieces, right? So you could say AD is proportional to BD and AB. So you could do AD over DB equals BD over DC or something, right? So these are all similar, so they're all proportional. So that's with doing numbers, right? You could do it with variables, and I'll do that quickly just to show you how the principle always carries, right? So we said A was X degrees. That means not C is 90 minus X degrees. 90 minus X degrees, right? And then that means that this is 90, that means angle B, DBC, right? We'll do that here. DBC equals 90 minus 90 parentheses 90 minus x. The x is the negative distribute, so it's 90 minus 90 plus x, and that gives us x. So that means DBC is x. That makes this 90 minus x. And again, all the triangle angles are equal to each other, which means the triangles are all proportional and all similar. So that's just the common way this works, right? And it only works if you have a right angle, right triangle. This is a rule. I mean, there's other ways you can make similar triangles, but in this method I'm talking about, it's when you're dividing the right angle. So you're going across to the hypotenuse and making a 90-degree angle on the hypotenuse, right? If you divided A, it wouldn't be the same method, right? We'd have to be doing something else to try to get them equal or proportional. So I hope this helps explain that. If you have more questions like this, let me know. I'm always happy to make quick videos on it, and I'll talk to you all soon.